Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So we will continue our last lesson, which is lesson 18. Okay, so 14.2, the learning outcomes is 14.2, which is thermodynamic process. Okay, so look at to the learning outcomes for this subtopic. Okay, the first one is define the following thermodynamic processes. Okay, so we have the first one is isothermal. Okay, the second one is isobaric. The third one is isobaric. And the fourth one is adiabatic. Okay, then the next linear outcome is discuss pressure against volume graph for all the thermodynamic processes. Okay, there are four common processes of thermodynamics. Okay, which is the first one is isothermal. Number 2 is isochoric, or also known as isovolumetric process. Okay, number 3 is isobaric process. And the last one is adiabatic process. Okay, actually what is meant by iso? Okay, the meaning of iso is same. Okay, so it means the process have the same temperature or volume or the same pressure. Okay, so for the first one, let's have a look to the definition of isothermal process. What is meant by isothermal? Isothermal process is defined as a process that occurs at constant temperature. Okay, so it means T1 is equal to T2. Okay, the temperature also can be related with internal energy. Okay, the equation for internal energy, as we know that internal energy is equal to F over 2 and RT. Okay, so in order to find the change in internal energy, so we have to minus U2 minus U1. So since U2 is equal to F over 2 and RT2 minus F over 2 and RT1, and since T1 is equal to T2, okay, so T1 and T2 is same. So when we minus, we will get the change of internal energy will be equal to 0. So delta U will be equal to 0. Okay, from first law of thermodynamics, Q is equal to delta U plus work done. Okay, so since delta U is equal to 0, okay, then we will get Q will be equal to W. Okay, the heat will be equal to work done. Next, there are two types of isothermal process. Okay, the first one is isothermal expansion. Okay, in isothermal expansion, all the heat absorbed by the gas is converted into work to expand the gas. So here, okay, we'll get Q is equal to work done, and the value of work done is positive. Okay, in order to expand the gas, so work done will be positive. Okay, the second one is isothermal compression. In isothermal compression, okay, the work done on the gas is lost as the heat lost to the surrounding. Okay, here the value of work done and the heat are negative. Okay, as you can see here, Q and work done both are negative because heat is lost to the surrounding and the work done is done on the gas. Okay, isothermal process also can be related with Boyle's law. Okay, in Boyle's law, when the temperature is constant, so pressure times volume will be constant, and we will get the equation of P1 times V1 is equal to P2 times V2. Second thermodynamic process is isochoric or isovolumetric process. Okay, from the name itself, here we can already make the assumption. Okay, if you don't know what is isochoric, okay, look at to the second name. It is isovolumetric. Okay, just now we already know what is the meaning of iso, right? It is means same, and then volumetric. So volumetric, it stands for volume. Alright, so we can know the meaning of isovolumetric process. It is defined as a process that occurs at constant volume. So it means the volume is constant and same. Okay, V1 is equal to V2. Okay, volume, we can relate the volume with the work done. Okay, if we got the positive value for work done, okay, it means the gas expand, and it also means that V2, the final volume, is greater than the initial volume. Okay, if we have the negative value of work done, which is work done is less than 0, so it means the gas is compressed. Okay, here when the gas is compressed, the final volume will be less than the initial volume. Okay, in isovolumetric, the volume is constant, so V1 is equal to V2. Then we will get the work done will be equal to 0. Okay, because there is no change in volume. Okay, from first law of thermodynamics, okay, Q, heat, is equal to the change of internal energy plus work done. And since work done is equal to 0, okay, so here work done is equal to 0, so we will get delta U will be equal to the heat. Delta U is equal to Q. In isochoric process, there is no isochoric expansion or isochoric compression, okay, because the volumes are constant. Okay, but from the equation of delta U is equal to Q, okay, we can explain in terms of the sign of delta U and also Q. Okay, if delta U is equal to Q and the values are positive, what is mean here is, okay, all the heat absorbed by the gas is used to increase the internal energy of the gas. Okay, so if the heat is absorbed, okay, if the heat is absorbed, so it means Q is equal to positive. Okay, and also delta U. Delta U positive, it means the internal energy is increasing. Okay, there is increasing in internal energy of the gas. So that's why delta U is also positive. Okay, what if the value of delta U and Q are negatives? Okay, what does it mean? If the values are negative, okay, the internal energy of the gas decreases as heat flows out of the gas. Alright, so you can notice here, negative of delta U, it means the internal energy of the gas decreases, and negative value of Q, it means that the heat flows out of the gas. Alright, next we can also relate the isochoric process or isovolumetric process with Gay-Lussac's law or pressure law. Okay, in pressure law, the volumes is constant, isn't it? Okay, so pressure against temperature will be equal to constant. And we can deduce the equation for pressure and temperature as P1 over T1 will be equal to P2 over T2. Next thermodynamic process is isobaric process. Okay, so what is meant by isobaric process? Okay, isobaric process is defined as a process that occurs at constant pressure. Okay, so it means the pressure is constant and delta P will be equal to 0. Okay, there is no change in pressure. Okay, because the pressure is constant. Okay, so from first law of thermodynamics equation, Q is equal to delta U plus W. Okay, so there are two types of isobaric process. Okay, the first one is isobaric expansion. So the equation that can be related with isobaric expansion is Q is equal to delta U plus W. Okay, this one. Okay, what is meant by isobaric expansion? Okay, which is all the heat absorbed by the gas is used to increase the internal energy of the gas and to do the work. Okay, so as you can see from this equation, okay, Q, delta U, and also work done, all are positives, right? Okay, so what is the meaning of positive sign here? Okay, so for the heat is positive when the heat is absorbed. Okay, positive Q means that the heat is absorbed, and delta U is positive because, okay, in isobaric expansion, okay, there is a change in internal energy of the gas. Okay, so it means the final internal energy is greater than the initial internal energy. So that's why delta U is positive. And for the work done is positive when the system is doing work. Okay, W positive when work is done by the gas. Okay, next for isobaric compression. Okay, the equation that associate with isobaric compression, it is negative Q is equal to negative delta U minus W. So what is the meaning? In isobaric compression process, okay, the work done on the gas is used to decrease the internal energy and loss as heat to the surrounding. Okay, so is it clear, right? Negative here because negative Q, negative heat because the heat is lost. Okay, and negative delta U here because of the internal energy is decreasing, and negative W here because the work is done on the gas. Okay, so isobaric process also can be related with Charles' law, okay, in chapter 13 that we already learned, right? So from Charles' law, volume over temperature will be equal to constant, okay, because the pressure is constant. So from there we can deduce the volume over temperature equation will be equal to V1 over T1 is equal to V2 over T2. Okay, the last process is adiabatic process. So what is the meaning of adiabatic? Okay, adiabatic process is defined as a process that occurs without the transfer of heat, okay, either into or out of the system. Okay, here adiabatic process is the process that occurs without heat transfer. So it means Q is equal to 0. Alright, so from first law of thermodynamics equation, Q is equal to delta U plus W. So since Q is equal to 0, okay, then we will get our equation delta U will be equal to negative W. Okay, adiabatic process also can be divided into two types, okay, which is adiabatic compression and adiabatic expansion. Okay, so from adiabatic compression, okay, the equation for adiabatic compression is delta U equal to negative W. Okay, delta U is equal to negative W. What means here, okay, our delta U is positive and the work done is negative, right? So as we know that work done is negative when the work done on the gas. Okay, when the work is done on the gas, so our work done sign will be negative. And here delta U is positive. So delta U positive here, it means the work done on the gas is used to increase the internal energy of the system. Okay. For adiabatic expansion, okay, the equation for adiabatic expansion, okay, we got negative delta U is equal to W. Okay, here the sign for delta U is negative, but the sign for work done is positive. Okay, it means the gas uses its internal energy to do the work. Okay, so it means the internal energy is decreasing. Okay, and the work is done by the gas. Alright, so next we will continue with the second linear outcome for subtopic 14.2, which is discuss pressure against volume graph for all the thermodynamic processes. Okay, so here we have a pressure against volume diagram, okay, for each thermodynamic process for a constant amount of an ideal gas. Alright, so now we have temperature curve of T1, T2, T3 and T4, okay, where T4 is greater than T3, T3 is greater than T2, and T2 is greater than T1. Okay, the temperature is increasing as it's going up. Alright, so now let's say we have point A at P1 and V1, okay, and then, okay, as you can see here, there is a curve between A to B. Alright, so the curve is represent the thermodynamic process. Okay, and the curve also must have the arrow. Okay, you must label the arrow because from the arrow we can notice either it is the compression or expansion process. Alright, so for point A to B here, okay, B is lies at P2 and V3. Alright, so here we can see that point A and point B are lies on the same temperature curve, isn't it? Which is T2. Okay, so temperature at A is equal to temperature at B. So what is the process? What is the thermodynamic process that occurs at constant temperature? It is isothermal process. Okay, so path A to B is known as isothermal process, in which temperature at B will be equal to temperature at A. Okay, next, okay, so look at the pink curve here from A to C. Okay, from point C, C is at P3 and V3. Okay, so here the curve A to C, the arrow is from A to C. Okay, so here we can see that pressure at A is P1. but the pressure at C is P3, so the pressure is changing. The temperature at A is T2 and temperature at C is at T1. Temperature also changing. Okay, volume at A is V1 and volume at C is V3, and it means the volume also changing, right? So all the physical quantities are changing. What is the process? It is adiabatic process. Okay, so for adiabatic process, here from A to C, so A is at T2 and C is at T1, and we know that T2, okay, T2 and T1, what is the relation between T2 and T1? T2 is greater than T1, so that's why Tc is less than Ta. Okay, temperature at C is less than temperature at A. Okay, so continue with the next process. Okay, so now we have A to D. Okay, point A is at P1 and V1. Okay, for point D is at P2 and also V1. So what is the constant physical quantity here? The volume, isn't it? Okay, so the volume is same for point A and point D. So what is the process that occurs at constant volume? It is isobaric process. Okay, so in terms of temperature, here we can see that point A is lies at T2. Okay, but point D is lies on T1. So which one has the greater temperature? Point A, isn't it? So that's why TD is less than TA. Okay, so we continue with the last process. Okay, the last process, okay, from this arrow here, we can see that the process is from A to E. Okay, the process is from A to E because the arrow pointed from A to E. Okay, so A is at P1 and V1, and point E is at P1 also, but V2. So we can see that the pressure between A and E are constant, isn't it? So the process is called as isobaric process. Okay, so for this isobaric process, it is from A to E. So point E is at temperature 4 and point A is at temperature 2. So which one has the greater temperature? E, isn't it? So that's why TE greater than TA. Okay, so that's all. I hope that all of you can understand this pressure against volume diagram, and you be able to draw your own thermodynamic process diagram. Okay, that's all. Thank you.